All right, welcome everyone. We're doing section 513 right now, which is solving algebraically. Some more, but now we're looking at absolute value equations and fraction equations. So we can extend our ideas, or we can extend our solving strategies of rewriting and undoing to absolute value equations and equations involving fractions. So this is how you solve absolute value equations. So remember, absolute value are those vertical bars. These are absolute value equations. And it's very similar to our other strategies. So reminder, the output for an absolute value must always be positive. So step one is you want to isolate the absolute value bars by undoing. So using that undoing strategy just to get those absolute value bars alone. So if we look at example 1 here, I want to get these absolute value bars by themselves. I'm using PEMDAS backwards to do that. So I undo addition subtraction first. So that minus 2 I have to undo by adding 2. So I have the absolute value of 2x plus 8 equals 20. Those absolute value bars are now isolated. So therefore I can go on to step 2. So the way we undo an absolute value, since the absolute value is the distance from 0, you need to make 2 equations. So equation 1, you drop the absolute value bars and keep the right side positive. In equation 2, you drop the absolute value bars and you make the right side negative. All right, so the way I'm going to undo, and then you solve the 2 equations by undoing. All right, so the way I'm getting rid of these absolute values by rewriting it as 2 separate equations. Drop the absolute value bars and keep the right side positive. I drop the absolute value bars and make the right side negative. So now I'm going to solve by undoing for these other 2, for these remaining equations. So subtract 8 and then divide by 2. So x equals 6 as one answer. And then I'll subtract 8 and divide by 2 again. And x is equal to negative 14. So why do we need 2 answers? Well, let's look up here. If I plug 6 in here, 2 times 6 is 12 plus 8 is 20. Absolute value 20 is 20. If I plug negative 14 in, 2 times negative 14 is negative 28, plus 28 is negative 20, and the absolute value of 20 is 20. So we have to get 2 answers to account for the inside being positive 20 and negative 20, because the absolute value of positive 20 and negative 20 is 20. So you're always going to get 2 answers. If we look at example 2, again, we're doing PEMDAS backwards, so I undo addition subtraction first. So I'm going to add 4. I then am going to undo multiplication division. You can never distribute through an absolute value. It's not like parentheses. So I have to divide by 3. So I get the absolute value. Remember, that just cancels out the 3. I still have the absolute value. The absolute value of 2x plus 7 equals 11. I want to undo the absolute value, and the way I get rid of that is by rewriting the equation as 2 separate equations. So I get 2x plus 7 equals 11. And 2x plus 7 equals negative 11. All right, and now I start solving. So I subtract 7. So I get 2x equals 4, divide by 2. X is equal to 2 as one answer. I subtract 7. And then divide by 2 again. And I get x equals negative 9. So 2 answers to negative 9 here. All right, one more example for you. Example 3 here. Again, I'm isolating the absolute value by undoing, so I would subtract 10 first. I get the absolute value of 3x plus 5 equals negative 6. And this is where we must remember the absolute value, the output for the absolute value must always be positive. So there is no x value in the world that I could plug in here, and then after I take the absolute value of that, I get a negative, because remember, the absolute value always has a positive output. So once you have your absolute value isolated, this number on the right must always be positive. If it's negative, guess what? That just means no solution. So you could have, I could have something like this. The only time there's no solution is when the absolute value is totally isolated. If I had a negative here and when I add it, it's positive. Once the absolute value is isolated, there's solutions, but no solution here. All right, go ahead and try these two on your own. We would divide by 4. And then I would write two separate equations. 2x minus 1 equals 5. 2x minus 1 equals negative 5. I would add 1. And then divide by 2. So we get x equals 3. Sorry about that. And then I add 1. And divide by 2 again. X equals negative 2 as my other answer. For example 2, I'd have to add 1 first, because again, I'm undoing the addition and subtraction. Then divide by 3 to undo that multiplication division. And the way I undo an absolute value is to rewrite as two separate equations. X plus 2 equals 3, and x plus 2 equals negative 3. And here, when I subtract 2, I get x equals 1, and subtract 2, x equals negative 5. That's our absolute value. Next is our fraction equations. And there's actually a lot of ways you can solve the fraction equations. I think this is probably one of the easier ways to do it. So this is the way I'm going to show you. If you have another way, feel free to do it as long as it works. So the way I do it is you find the common denominator. So in this case, for example, 1, I have a 4, a 3, and a 6. 4, 3, 6. First common multiple, or what number divides into all of them, or what's a larger number that I can divide by 4, divide by 3, and divide by 6, and get a whole number out, will be 12. So our common denominator is 12. 12 divided by 4 is 3, 12 divided by 3 is 4, and 12 divided by 6 is 2. So that's our common denominator. Once I have that, I'm going to multiply the entire equation by the common denominator. And remember, what that means is remember that you are multiplying by the common denominator on the top and 1 on the bottom. There's always a 1 on the bottom. So what I'm doing here is I'm going to take my entire equation and I'm multiplying by 12 over 1. So the way I'm going to do this is I'm going to write it like this. 12 times the quantity of x minus 5, and then multiplying the bottom by 1, so that stays as 4, plus 12 times 1 is 12. I'm multiplying the bottom by 1, so that stays at 3. Equals, and I'm multiplying 12 times 5 is 60, and I multiply the bottom by 1, which is 6. And so what should happen after you do this is step 3. If you divide, you should be able to divide every term and not get any remainders or anything. You should be able to divide every term, and then there will be no more fractions, like magic. It's like math and magic, I call it. So let's see if it works. So right here, 12 is a factor, so I can just reduce that fraction. 12 divided by 4 is 3. Boom, no more fraction there. Plus 12 divided by 3 is 4. Boom, no more fraction. And 60 divided by 6, x is 10. So again, I have no more fractions here. It's like magic. They're all gone. And so now I can just solve by undoing. So I'm going to subtract 4. And I would end up with 3 times the quantity of x minus 5 equals 6. And now I can solve this by undoing. You can distribute if you want. I'm just going to divide by 3. It's a couple less steps if you solve by undoing. So that would give me just x minus 5 equals 2. Add 5, and I get x equals 7. All right, let's try example 2. I need a common denominator of 3, 2, and 6. That would be 6. 6 over 1. So I end up with 12x divided by 3 minus 6 divided by 2 equals 6 times the quantity of x plus 5 all divided by 6. So if I'm ever multiplying by more than one term, like here I multiply by one term, so I actually did the multiplication. If I'm ever multiplying by 2 or 3 terms, I usually just put the multiplication in front because you should be able to reduce that fraction before. And it makes it a few less steps. All right, so now I do my division, my math, the magic. 12x divided by 3, take your magic wand, 4x, no fraction. 6 divided by 2 is 3, no fraction. 6 divided by 6 is 1, so I'm left with just 2x plus 5. Boom, no more fractions, like magic. Now I want to get all my x's on one side and all my constants on the other. So I'm going to add 3 and subtract 2x. So I end up getting 2x, or x is equal to 4. All right, try these other two on your own. All right, so for number 1, again, we're going to have a common denominator 6. So I'm multiplying the entire equation by 6 over 1. So that would give me 6x divided by 2 plus 12x divided by 3 equals 6 times the quantity of 5x plus 4 all divided by 6. Again, what we should be able to do now is just divide. Here comes the magic. 6x divided by 2 is 3x plus 12x divided by 3 is 4x. The 6's cancel. We're left with just 5x plus 4. Add my like terms. And then I'm going to get all my x's on the left. So I get 2x equals 4. And x is equal to 2. All right, one more for number 2. Common denominator would be 8. So I'm multiplying everything by 8 over 1. So that'll give me 8 times the quantity of 4x plus 2, all divided by 2, minus 56 divided by 8 equals 40 divided by 4. Do our magic. 8 divided by 2 is 4. So 4 times the quantity of 4x plus 2. 56 divided by 8 is 7, so minus 7, and that's equal to 10. I'm going to add 7 now. That's 17. In this case, I am going to distribute because the answer is not going to come out very nice. So I'll get 16x plus 8 equals 17. I'm going to subtract 8, get 16x equals 9, and then divide by 16. So x equals 9/16 for here. And that's okay. Sometimes with these fraction answers, you're going to get some messy equations or answers. All right. Thank you.